You are watching Macro TV. We are busy with the Solow model, study unit 4, chapter 8 of Fourier and Berger. And in this video, what we will be doing is looking at how does this total production function of ours work? When do we move along this curve? When do we shift the curve? And then we can have some preliminary conclusions about what are some policy decisions you might want to make for long-run growth. So let's start with a change in capital. So if capital increases and labor remains constant, labor doesn't change, that means our capital-labor ratio will increase, and we will have a move along the total production curve to the right, which will also result in an increase in your income per person, or your GDP per capita. If labor is increased, and labor is increased while capital remains constant, then your capital-labor ratio will decrease, and you will again move along the TP curve, but this time towards the left, because there will be a reduction in capital per person, and ultimately a reduction in your GDP per capita. If both capital and labor increase at the same proportion, then your capital-labor ratio will remain constant, and so will your GDP per capita. If technology is increased, then your output per capita will increase without any change necessarily to capital or to labor, and because of that, your entire total production curve will then shift upwards, resulting in a higher output per person without a change to your capital-labor ratio. We're now going to look at each of these separately and show you how we can draw the diagrams around these curves. So let's look at the first one, a change in capital. Now notice that I'm doing an increase in capital here, but you could do the opposite, and then that would also apply. So if capital increases, but we assume that labor does not increase. In other words, K over N, the K part increases, the capital, without a change in the denominator, labor, which means the entire capital-labor ratio increases. And you will have a move along the total production curve, with the result being a higher output per person. But notice that the higher output per person will diminish the more your capital increases. And this is because of the diminishing marginal returns to capital. So we could, as a strategy to increase production, increase our capital, but the more capital we add, the less we're getting out of that capital. And there's kind of an implicit limit then to how much capital you can use to increase production. If we look at labor, if we were to increase labor, we would then see a reduction in our capital-labor ratio, right? Because the denominator has increased while the numerator has remained the same. So K over N will decrease, and that will be a move to the left, and you will see a lower output per person. Now we could do the opposite, and we could decrease the labor force, and that would actually result in a higher capital per person, right? Because the amount of capital you now have gets to be used by few people, if you want to see it that way, and the output needs to be divided by few people, so our output labor ratio would move in the opposite direction, would increase. And again, diminishing marginal returns to labor results in this TP slope being positive but diminishing over time. So if the strategy was to decrease labor and increase your output per person over the spectrum, you would ultimately be capped or limited by the slope of the TP curve, and you can only decrease labor up to a point. So that could be a strategy, but it has limitations. Now, This one we add where we take capital and labor and either increase or decrease them at the same proportion because we want to show you the proportionality. In both the previous cases, it was absolute. Capital increases, but we assume labor remains constant. Or labor increases and we assume capital is constant. In this case, we change both of them at the exact same proportion. And then you would have zero change to your capital labor ratio and no change to your output per person. This implies that if we were to change capital proportionally more than the change in labor, labor doesn't necessarily have to remain constant. But as long as there's more capital increase than labor increase, we'll see an increase in output per person. And the same with our second case where we looked at labor. If labor increases more than our increase in capital, you would see a reduction in output per person. If they both change proportionally, then you will see no change. If we then look at change in technology, now change in technology is quite a cornerstone of the Solow model. It really is, the Solow model really tries to show how technology or productivity is a key to sustained economic growth. If we increase our technology or productivity, we would increase our output per person, but not necessarily either capital or labor would have to change. So capital labor ratio remains constant while your output per person, GDP per capita, increases. To show that graphically, we would have to shift the TP curve upward, as you can see here. Now, in every other case, there was diminishing marginal returns when we changed capital and when we changed labor. So there were limitations to how far you could take policy by changing capital and labor to change economic growth. But theoretically, productivity and technology could increase infinitely. So we could always shift the total production curve upward if we can improve the productivity of both the labor force and capital. So in this video, we just had a look at how the dynamics of the total production function looks graphically. How does our Solow model account for changes in labor, in capital, and technology? Stay tuned.